In the previous lecture, we introduced trusses and solved an example using the method of joints. In this lecture, we continue with the method of joints and solve two more examples using this method. So, I will take a simple truss like this, each angle being 45 degrees. These are the joints. You can see there are 6 joints. So, j equals 6, 2j minus 3 is 9, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 members. I am going to name this A, B, C, D, E and F and apply a load of 5000 newtons at E. I want to calculate the force in each member of this truss. So, ideally, if I start with this point, I would take point E. The force on point E is 5000 newtons, and then a force due to member BE, let me call it F BE, a force due to member F ED, a force due to member FCE, and a force due to member FE. Remember, all the forces are acting at the same point, therefore, torque equation is automatically satisfies. The only equations I have at my disposal are Fx equal to 0 and summation Fy equal to 0. And therefore, I have only two equations that I can apply at this point. However, the number of unknowns is 1, 2, 3 and 4, and therefore, I cannot directly apply these two equations and get the answers right away. For that, what I should do is get to those points where there are two unknowns only, and those points are A and B, A and D. So, first thing is to get the forces at A and D and then go to other joints from there onwards. So, let us do that. To get the forces at points A and D, let me make this again. A, B, C, D, E and F. There is a force of 5000 newtons acting downwards. Let me take the entire truss as one unit. Let the normal reaction at D be ND, let the normal reaction at A be NA, and there is this force acting downwards of 5000 newtons. I have not been careful in making this to scale, but let the length of these small straight rods be L, so that this diagonal rods is L root 2, this length is also L root 2 and so on. So, first thing I want to do is get NA and ND. The simplest thing to do in this case would be to apply the torque equation about this point A. When I apply the torque equation about A and make it 0, I get 2L times 5000 is equal to 3L times ND, and therefore, ND comes out to be 10,000 over 3 newtons. Once I know ND, then summation Fy is equal to 0 gives me NA plus ND is equal to 5000, and this gives me NA to be 5000 minus 10,000 over 3, which gives me 5000 over 3 newtons. So, now if I look at this truss, try to make it to scale. Now, I know there is a force acting here 10,000 newtons over 3. There is a force acting here downwards 5,000 newtons. There is a force acting upwards here 5,000 over 3, and this is A, B, C, D, E and F. Now, at point A, there are two unknowns, force due to AB member and force due to AF member, and therefore, if I bring this pin in equilibrium, I have two equations, summation f x equal to 0 and summation f y equal to 0. I can solve for both the forces. So, let us do that at point A. So, at point A, the pin at A is in equilibrium under a force which is 5,000 over 3 newtons acting upwards. To balance this, I need a force on this F A B acting in this direction, and to counter the x component of F A B, I need a force in this direction, which will be F A F. I have already anticipated the directions of these forces. Obviously, the force on member A B due to the pin, therefore, would be in this direction. So, this is a compressive force, and force on F A F, this is A B A F, would be in this direction, and this will be a tensile force. So, the member A B is under a compressive force and member A F is under a tensile force. Let us now calculate these forces. This angle is given to be 45 degrees. Summation f y is equal to 0 gives me f A B over root 2 equals 5,000 over 3, or f A B equals 5,000 root 2 over 3 newtons. Similarly, summation f x equal to 0 gives me f A F to be f A B over root 2, which is equal to 5,000 over 3 newtons. So, now I have gotten forces on two members of the truss, namely A B and A F. If I make it again, I know the force here is 5,000 over 3, force here is 10,000 over 3, force here is 5,000. I know the force in this member and in this member. Now, if I go to point F, A, B, C, D, E, or point B, I have two of the three forces, I have one force which is known, and therefore, I can calculate the other two forces. Let us go to point B. The pin at B is under equilibrium due to a force on A B, which is compressive. So, it pushes the pin in this way. There is a rod like this, and there is a force B F, let us call it F B F. There is a force F B E, and there is a force F B C. Sorry, I said earlier that at point B I can solve, but no, I have 1 known and 3 unknowns. Equations are only 2, so for point B I cannot solve, but certainly point F I can solve, because point F there is one known force FAF, and FAF we had determined it to be a force which is tensile, and therefore it pulls the pin at F in this direction. There is a force FE and there is a force FBF. From summation Fx equal to 0, we get that FE is equal to FAF, which is equal to 5000 over 3 newtons. Let me just check whether this force was really tensile or not. This was tensile, so it pulls the pin in. Now, summation Fy is equal to 0 gives you right away that FBF is equal to 0. The moment I know FBF, I know this force and I know this force. There are only 2 unknowns at point B. I can solve for forces FBE as well as FBC. Let us do that. So, let us first write the forces that we have determined so far. We have determined FAB, and FAB was a compressive force, and its magnitude was 5000 root 2 over 3 newtons. We have determined FAF, which is tensile, which is equal to 5000 over 3 newtons. We have determined FE, which is also tensile, and its magnitude is 5000 over 3 newtons. We have determined FBF to be 0. We are now ready to analyze point B. Let us see, point B has a force pushing it this way, because FAB is compressive, it pushes by Newton's third law the pin out. There is no force in BF direction. There is a force FBE in this direction, and there is a force, let us assume now, to balance forces FBC in this direction. These are at 45 degrees each. Right away you see that this is FAB, that FBE must be equal to FAB. This comes from summation Fy equal to 0, and therefore FBE, and the direction also comes out to be right, should be equal to 5000 over 3 newtons. The x component FBC balances the x component of FAB as well as FBE, and therefore I can write right away that FBC must be twice of the x component of FAB, or F. So, this is FAB is 5000 times 2 root 2 newtons, twice the x components of FAB or FBE. Let us do that now. So, at point B there is a force FAB working this way, FBE working this way, and FBC working this way. FAB is pushing the pin out, so this is compressive, is 5000 root 2 over 3, FBE we have just determined, but FBE pulls the pin in, and therefore, by Newton's third law, pin pulls it out. This is tensile, but its magnitude is 5000 root 2 over 3, and FBC from summation Fx equal to 0 would come out to be 2 times the x component of FAB, or FBE is the same thing. So, I can write this as actually FAB cosine 45 plus FBE cosine of 45, which comes out to be 2 times 5000 root 2 over 3 times 1 over root 2, which comes out to be 10,000 over 3 newtons. And since the pin is being pushed out, the pin will push the rod in, and therefore, on the rod the force FBC is compressive, and this is of the magnitude 10,000 over 3 newtons. So, now we have found forces. Let us make this truss again. In this member, in this member, in this member, this member, this member, and this member. Only members which are left are A, B, C, D, E, F. The members CD, CE, and ED. One can keep going from B onwards to C and D and E, or work from D backwards. For example, at point D, we have already calculated that there is a force of 10,000 over 3 newtons working upwards. Due to the CD, there will be a force FCD acting this way. This would give an x component, and to balance that, I should have a force FED acting this way. So, this is point D. Summation Fy is equal to 0 gives me that FCD over root 2 should be 10,000 over 3, or FCD is equal to 10,000 root 2 over 3 newtons. And therefore, again by summation Fx is equal to 0, I will get that FED is equal to 10,000 over 3 newtons. So, immediately we have found the force in this member as well as this member. The only member now left is FCE. Let us now calculate the force on the member that is now left, that is FCE. This we have calculated, this we have calculated. The only member left is FCE. Let me write this again: A, B, C, D, E, F. For this, I will take point C, which is in equilibrium under the forces of FCD. We have already calculated FCD to be of compressive nature, and therefore, it pushes C out. Then there is a force FBC, which we have calculated earlier, and let me just have a look at that. FBC was calculated to be 10,000 over 3 newtons, and it was compressive. So, FBC was compressive, and therefore, it will push point C in this manner. FCE is what we want to calculate, and these are the three forces under which the system is in equilibrium. Right away you can see that summation f y equal to 0 would give me f c e to be equal to f c d over root 2, and we have already calculated f c d to be 10,000 over 3 times root 2 newtons, and therefore we get this to be 10,000 over 3 newtons. At this point we can also make a consistency check, because at this point if I have done my calculations correctly, the x component must vanish automatically, and that it does. We can see, because this is f c d with a negative sign, cosine of 45 degrees plus f b c. f c d was calculated to be 10,000 over 3 root 2. So, this comes out to be minus 10,000 over 3 newtons, plus f b c was calculated to be, and we can see that from the previous slides, f b c was calculated to be 10,000 over 3 newtons. So, this comes out to be 10,000 over 3 newtons, which is 0. So, we are consistent in our calculations. Let us now tabulate all the forces that we have calculated. All the forces that we have calculated are A, B, C, D, E, F. When this truss is loaded with a 5,000 Newton load at point E, are F A B, which came out to be 5,000 root 2 over 3 newtons, and this was compressive. Then F A F, which was tensile, and it came out to be 5,000 over 3 newtons. Then F B C, which came out to be compressive, and its value was 10,000 over 3 newtons. Then F E, which came out to be tensile again, and its value was 5,000 over 3 newtons. 1, 2, B C, F E are done, 1, 2, 3, 4 members. Then F B E came out to be tensile, and its value was 5,000 root 2 over 3 newtons. F B F came out to be 0. So, we have done B F, we have done B E. F C D came out to be 10,000 root 2 over 3 newtons, and this was compressive. F C D we have done. F C E came out to be, we just calculated this, 10,000 over 3 newtons tensile, and F E D came out to be 10,000 over 3 newtons tensile. You can go back and check these answers yourself. Next question is, what happens if each of these members, in addition to this load, had weight themselves? So, here is a load of 5,000 newtons, if each member, let us say, had a weight of 500 newtons. In that case, as I remarked earlier, what we would do is divide this weight equally at each point. Thus, pin A would carry the weight of member AB, which is 250, and member AF, which is 250, additional weight of 500 newtons. The reaction would change correspondingly. Point B would carry the weight of AB, BF, BE, and BC. So, it will carry an additional weight, each half of each. So, 250 times 4, 1000 newtons, in addition to whatever else is being done. I would leave this exercise for you to complete as to how the forces in each member would now change when I put this additional load due to the weight of each member onto these pins.